Hello gentlemen, as you realise I'm not here today, so I'm going to take you through a few of these steps of exercise 1.4. So we're just looking at something very simple, question 1a and exercise 1.4. It says 6a take 2 is greater than 28. Now when you're solving inequalities, you treat the inequality sign, which is this thing here, as being like an equal sign. So all we have to do is solve it. 6a is greater than 30. Divide both sides by 6. A is greater than 5. Now if you are asked to do this on a number line, then what I suggest you do, you make that your number 5, your number 4, and up here of course you've got 6, 7, 8, etc. Since it's greater than and not necessarily equal to, you put the circle around the 5 and you put the arrowhead like that. Now if we went to something like question 2, realistically, I've got that, where am I? Oh, yeah, we try it now. Okay, there we go, question 2a. This time we have negative 8 is less than 2a, but 2a is less than 12. What you have to do in this case here is very simply is you break it up into two questions. And so therefore my first one will be negative 8 is less than 2a. So therefore divide both sides by 2. Negative 4 is less than a. For the second part, we have 2a is less than 12. In this case, a must be less than 6. So now you have two solutions that you need to graph on your number line. Now let's just make this 0. 1, 2, 3, 4, 5, 6. And negative 1, negative 2, negative 3, negative 4. So it says negative 4 is less than a. So once again we have one of these situations where you can put the circle around there, and a is less than 6, you put the circle around from there, and this time it's joined up between them. If we take this one step further, let's just look at a question like question 3. Now which one am I going to be doing? Question 3b will do fine. So negative 7 take 3h over 4 is less than or equal to 5. Same thing, solve it as you would normally do. So we're going to multiply both sides by 4, so that gives us 20. We are now going to add 7 to both sides. Negative 3h is less than or equal to 27. Now this is where the situation now becomes a little bit different. That's a negative 3. When you're solving inequalities and you are dividing by a negative, your inequality sign reverses. So now with 27 divided by that, we get negative 9. So it's really important that that is reversed. It's only when you divide by a negative or multiply by a negative. You must do that. If you don't, you're going to get the wrong answer. So now let's go back, and there's my number line. Let's try negative 7, negative 8, negative 9, negative 10. So all we have to do now is I circle my 9, but this time, because it's equal to, I'm going to colour it in. And is that correct? No, it's not. It actually has to go this way, because it says h is greater than or equal to negative 9. So don't get caught out by that. Alright, now one step further, if we go down to question 4, we have something called now a new, we now have something new called absolute value. Now, the easiest way to explain absolute value is it's the distance a numerical number is away from the value of 0. It's a distance. So, e.g., if I had the absolute value of 2, it will be 2. That means to say it is 2 units away from 0. If I have the absolute value of -6, and that's, by the way, is what these two vertical lines is, it'll be 6, because it's 6 units away from 0. Now, the easiest way to operate with this is that if it's a negative number within inside the two vertical lines, make it a positive. So, for example, if I had this absolute value of -7 minus the absolute value of 6, that's exactly the same as saying 7 take 6, which equals 1. And that's about all there is to that. So, you guys can have a go at doing these now. But I'll do one more. How about if I try question 5c? And it says now 2x plus 5, the absolute value of 2x plus 5 equals 4. So what it means is that x could be positive, it could be positive, and it could be negative to solve it. Okay, so e.g. 2x plus 5 could equal -4, or 2x plus 5 could equal +4. Either one of those equations will actually give you the right answer. I'll explain it. So let's see, if we look at 2x plus 5 equals -4, 2x will equal -1, x will equal -1/2. If I put -1/2 back into the original question, I'll get +4, and that's okay because that's what it equals. Or I could have 2x plus 5 equals 4, 2x equals -1, probably 4. Oh, sorry, I've made a blundering error here. How about I go back a whole bunch of steps because I can't. This should be -9, so therefore x would equal -4.5. Or 2x plus 5 equals 4, 2x equals 1, x equals -1/2. What I found is I have two values for x, both of which, when I take the absolute value, will give me the value of 4. So you have to work out one of your equations has to equal the negative of the equals, and the other one has to equal the positive, so you can get two answers. Then you just go ahead and graph it as you would, and away you go. So I'd like you guys now to try exercise 1.4, questions 1 through to 5. So that is exercise 1.5, questions 1 through to 5, doing the odd parts. And that's a big smile from Mr. Moore.